Hey everybody, here is problem 9.2.9T. It says, according to a lending institution, students graduating from college have an average credit card debt of $4,100. A random sample of 40 graduating seniors was selected, and their average credit card debt was found to be $4,467. Assume the standard deviation for student credit card debt is $1,100, using an alpha of 0.01. Complete the parts below. So the first thing we have to identify to do this problem is whether or not we know the population standard deviation, or the sigma. And so the population standard deviation is given, this says, it doesn't say assume the standard deviation for this sample, it says assume the standard deviation for student credit card debt is $1,100. So that's the population standard deviation. So since we know that, this is the formula we will use to figure out our z-test statistic. So as always, let's just start with what we know. We know that the expected mean is $4,100, right? That's the claim, if you will. And then we also know that n, or our sample size, is 40. And we know that x bar, or our sample mean, was 4,467. We know our population standard deviation is 1,100, and we have an alpha of 0.01. So for me, if I just start by typing down everything I know, then I can go from there. So even though the first thing it asks us is determine our null and alternative hypothesis. So again, the null hypothesis is always the claim. So the claim in this case from the lending institution is that the population mean is $4,100. So the alternative hypothesis is that it is not equal to 4,100. All right, so next they're going to ask us to calculate our z-test statistic. So I'm just going to call this z-test. And the z-test statistic, when our population standard deviation is known, is found by x bar. Whoops, I should do an equal sign first. Equals our x bar, which is the mean of our sample, minus our mean of the null hypothesis, or expected mean for the null hypothesis, which is 4,100. Then we're going to divide that by our population standard deviation divided by the square root of n. So there's our z-test statistic. All that means is that is the z-score. The z-score for this mean of 4,467, given an expected mean of the population of 4,100 with a standard deviation of 1,100. That's what that means. So our z-test statistic to 2 decimal places is 2.11. Now it's going to want our critical z-score. So remember, because this is an equal or not equal to on our hypotheses, this is a two-tailed test that we're dealing with here. And so if you remember from last chapter, our critical z for a two-tailed test it's going to be the z of the alpha divided by 2. And so I always use absolute value of that, so I get the positive number. And then it's the absolute value of norm.s.dist. I'm sorry, .inverse.inv, where my probability is alpha divided by 2. And that's going to be my critical z. So we can see right there that our z-test statistic falls within our critical z's. 2.58. Whoops, maybe I did something wrong. Let me make sure I got that alpha right, 0.01. And then this is norm.s.inverse of the alpha divided by 2. Oh, I know why, because, okay. So because this is a two-tailed test, it wants us to do both ends of it, negative 2.58, comma, 2.58. That's why. So it wasn't that my math was wrong. It was that it wanted me to include the negative and positive of that. So these critical z-scores, what they represent is, given our alpha, how far away, remember this is in z, so how many standard deviations away from the mean, plus or minus, we would have to go before we would question whether or not our test statistic was valid. Okay, so the question is going to be, because our test statistic in this case, it falls within the critical values, meaning it's not as far away from the mean as the critical scores are, then I'm going to have to not reject the null hypothesis. So if my test statistic was greater than 2.58 or less than negative 2.58, then I would have enough evidence at an alpha of 0.01 to reject the null hypothesis, to say it really does look like this can't be an average of 4,100. Here, even though our sample is more than 4,100, it's not enough more than 4,100 that we're willing to say we should reject that. The last part of it, it's going to ask me for a p-value. The p-value just means what's the probability of getting finding a number or z-test statistic that's that high. Okay, so the way I do that is I have to find my p-value, I'm going to do this equals my norm dot s dot dist. It's going to ask for my z-score, which I'm going to give it, and I'm going to say that's true. And what this will do is it will return to me the probability of getting less than a z-score of 2.11, which is going to be quite high. So I need the probability of getting greater than 2.11 or less than negative 2.11, because this is two-tailed. Okay, so my p-value is going to be this amount. So 1 minus this amount times 2. Okay, so if it were a one-tailed test, it would just be 1 minus this amount. So I'm going to say 1 minus that whole amount times 2. It doesn't like something. There we go. There's my p-value. We got about a 3.4% chance, or 3.5, so 0.035% chance of actually getting that test statistic. What that means is if we had an alpha of 0.05, this thing would be totally different. And then we'd be rejecting our null hypothesis. But because we had such a tiny alpha, actually not 0.5, it would have to be 0.1. Anyway, there we go. So that is the end of 9.2.9-T. Hopefully that was helpful to you.